Hello class, this is Mr. Sutton, and today we're going to be talking about properties of quadrilaterals. So there's going to be a lot of things to put down in the notes. This is probably going to be a shorter video, but there's a lot of definitions that we need to cover here. So first we're going to start with quadrilaterals themselves. So that's a four-sided polygon, so any shape that has four sides. So we got some different examples here. All of these shapes have four sides, and the interior angles of a quadrilateral add up to 360, just like we talked about. The interior angles of a triangle add up to 180. The interior angles of a quadrilateral add up to 360, so we can use this piece of information to find missing angle measures or to solve for x in different problems, just like we do for triangles. So make sure you have this in your notes. Next, we're going to talk about trapezoids. So a trapezoid is a type of quadrilateral that has at least one pair of parallel sides. So here you can see we have the parallel bases. So a trapezoid, the parallel sides we call the base, and then the not parallel sides we call the legs. So you want to write down these definitions and include a picture with, the labels. Next, we have the isosceles trapezoid. So an isosceles trapezoid is a trapezoid, and it has one pair of congruent legs also. So the legs are the same measure. And then we have the congruent base angles. So these angles down here are congruent, and then these angles up here are congruent. And we'd also have these angles would be supplementary, because we have these parallel lines, and then this would be a transversal. So these are actually same side interior angles. So these angles would be supplementary. Same over here. So you can use that information to find missing angles as well. So given just one angle, let's say this is 60 degrees, we would be able to find the other four because this would match. And then these would be supplementary, so that would have to be 120. 120, and then these would all add up to 360. Next, we have a parallelogram. So a parallelogram is a quadrilateral, and it is a trapezoid. So all the stuff we said about trapezoids is true here, but it has some additional requirements. So the parallelogram has two pairs of parallel sides. So the trapezoid had at least one, but the parallelogram now has the other sides parallel as well. Opposite sides are congruent for the parallelogram. So this side's congruent to this side. This side's congruent to this side. Opposite angles congruent. So this angle is congruent to this angle. This angle is congruent to this angle. And then consecutive angles supplementary. So these are supplementary. And then same thing with these. So they add up to 180. And then the diagonals bisect each other. So we have the diagonals being cut in half. So we have this half is congruent to this half, and then this half is congruent to this half. So you want to make sure you have all of those properties down, as well as some pictures to, show what those properties look like. Next, we have a rectangle. So a rectangle is a quadrilateral, four sides. It's also a parallelogram. So it's also a trapezoid. So it has all of those properties we just talked about from the parallelogram, but it has some others as well. So the rectangle has all angles congruent, unlike the parallelogram just has the opposite angles congruent. The rectangle, all of the angles are congruent, and they're all 90 degrees. So we have the opposite angles still congruent, and the consecutive angles still supplementary, but now they're all actually 90 degrees. So we have four right angles, and this time the diagonals are congruent as well. Before, with the parallelogram, we just had the diagonals bisecting each other, but they're not the same length. With the rectangle, the length of the entire diagonal is the same. So these two lengths are the same. Right? So make sure you have those properties as well as a picture down. Next, we have the rhombus. So the rhombus is a quadrilateral, and it is a parallelogram as well, just like the rectangle is. Difference between a rhombus and just a plain parallelogram is the rhombus has the extra property of having all four sides congruent. So the rectangle has all four angles congruent. The rhombus has all four sides congruent. And with the rhombus, you have the diagonals are perpendicular. So the diagonals are not necessarily congruent, but they are perpendicular. They form a right angle. All right. So make sure you have those properties down as well as some pictures. And then we have the square. The square is a quadrilateral. It's also a parallelogram. It's also a rectangle and a rhombus. So it combines all of those properties together. It's a parallelogram. It has opposite sides parallel. It's a rectangle because it is a parallelogram, but also has four right angles like the rectangle does. And it's a rhombus because it's a parallelogram that also has all four sides congruent. So it meets all of those qualifications. So it has all of the properties of all of these things, right? So we have the congruent diagonals. We have the diagonals bisecting each other. We have the diagonals are perpendicular to each other. All of those diagonal properties are true for the square as well. So go ahead and make sure you have those properties down and some pictures for that. And then finally, we have the kite. So the kite is a quadrilateral. The kite does not have any parallel sides, so it doesn't fit under trapezoid, but it does have two pairs of consecutive congruent sides. So this side's congruent to this side, and this side's congruent to this side. And we also have perpendicular diagonals for the kite, similar to the rhombus. So that is your properties for the kite. So those are your main quadrilaterals. And this is kind of the Venn diagram that it shows on Delta Math, which shows how all of these shapes relate to each other. So you have the quadrilateral. So everything inside is a quadrilateral. And then within quadrilaterals, you have trapezoids. So trapezoids have at least one pair of parallel sides. Within trapezoids, you have parallelograms. Parallelograms have at least one pair of parallel sides, but they also have the other pair of parallel sides, so two pairs of parallel sides. So all of the parallelograms fit inside trapezoids. So then inside of parallelograms, we have the rectangles and the rhombuses. The rectangles being a parallelogram that has four right angles, the rhombus being a parallelogram that has four congruent sides. And then the overlap of rectangles and rhombuses is the square. So the square is a parallelogram that has four right angles and four congruent sides. So there's your square. The only thing that's not in this chart is the kite. And the kite would be outside of the trapezoid. Like I said, the kite does not have at least one pair of parallel sides. So it would be kind of in its own box here. Outside of the trapezoids, but within the quadrilaterals. So, not sure why it doesn't include the kite for this. Probably just because it doesn't share any of the properties of the trapezoid, so it doesn't really fit in. But the kite would be the only thing we're missing here. So, I believe that's all I have. Yep. So, make sure you have all of these properties in your notes, as well as some pictures explaining what the properties are. We'll go deeper into parallelograms in the next lesson because there's a lot of properties to uncover inside the parallelogram, rectangle, square, rhombus area. But that's just kind of your overview for all of the quadrilaterals. If you have any questions, let your teacher know, and have a good day.